After we talk about the problem 12, let's look at the page 312. Let's look at the tree diagram summary on how to use the tree diagram. It says conditional probabilities start at zero condition. Let's look at the tree diagram in the problem 12. So this conditional probability start at its condition. Non-conditional probabilities start at the beginning of the tree. So this non-conditional probability and this non-conditional probability start at the root of the tree, the beginning of the tree. Multiply when moving horizontally across a limb. So along a limb, across a limb, horizontally, we multiply the probabilities on this branch and this branch. Add when moving vertically from limb to limb. So when we want to find the probability of second car is a king, then we just add the products we obtain from this limb and also this limb. So this is to add when we move vertically from limb to limb. We will see one more example on how to use this tree diagram summary. Now let's look at the example 5 on the page 312. It says, Big Farm Bicycles manufactures its product in 2 plants, one in Korea and one in Korea. The Korea plant manufactures 60% of the bicycles. 4% of Korean bikes are defective, and 5% of Korean bikes are defective. Now, part A, draw a tree diagram that shows this information. And part B, use the tree diagram to find the probability that a bike is defective and came from Korea. And part C, use the tree diagram to find the probability that a bike is defective. Part D, use the tree diagram to find the probability that the bike is defect-free. Okay, let's go to the whiteboard. This page 312, example 5. So let's first define the events, and we let K be the event that the bikes are made in Korea. And D be the event bikes are defective. And P be the event bikes are made in Korea. Now let's go back to the problem and we try to list all those knowns. And it says 60% of the bikes are made in Korea. So the P of K is equal to 0.6. Then what is the P of P? What is the P of P? So definitely this is equal to 1 minus P of K. Right, so it's equal to 0.4. 40% of bytes are made in period. And it says 4% of Korean bytes are defective. So actually this 4% is talking about a conditional probability. That is a conditional probability of the event that bytes are defective, given that the bytes are from Korea. So this is the conditional probability of D, the bytes are defective, given that the bytes are made in Korea, K. So this is equal to 0.044%. And then it says 5% of the Korean bytes are defective. This is talking about another conditional probability, P of D. The bytes are defective, given that the bytes are made in period. So given that P, and this is equal to 5%, 0.05, right? Now let's try to find the conditional probability that bytes are defect-free, given that the bytes are made in Korea. So this is the conditional probability of D prime, given that K. And we know this is equal to 1 minus P of D, given K. Actually, we have this general formula. It says P of the A given B is equal to 1 minus the P of A prime given B. This is just a similar formula to one rule about the probability, that is a P of E equal to 1 minus the P of the E prime. So this formula still holds for the conditional probability. So now we have this guy equal to 1 minus 0.04, and this is equal to 0.96. And similarly, we have P of D prime given P, and this is equal to 1 minus P of D given P, and this is equal to 1 minus 0.05, and this is equal to 0.95. So now after we figure out all these numbers, then we may use them to draw a tree diagram. Let me move to the next page. So a tree diagram